So we have review today. Next time will be the exam 5, right, on Thursday. And then next Tuesday is the schedule for the final exam. And that's gonna be same time, but you get 3 hours to do it, right? If you wanna come early, you can. I'll be here from 5 o'clock, and I could probably, 5 o'clock to 10 o'clock, I guess. So if you wanna come early and get it done so you don't have to stay so late, or if you can't because you have work, that's fine, whatever you need to do. Another option, I just put out there so you can take it in the testing center. If you need an extra day or two, you have until next Thursday to take the exam, the final exam. Good? So, your call. All you have to do is schedule a time to take it in the exam center if that's what you want to do. Okay?
I'm sorry, you say Tuesday is when you plan on having the exam?
Yeah, Tuesday is the final exam. Exam 5 is going to be this Thursday. Good?
Will you be here early as well Thursday or not?
Yes, I'm here. I have 2 classes. My first class goes from 5 to 7-ish, and this class goes from 7 to, so if you want to take the exam 5 early, there's plenty of seats in here, so, yep, that works. We good? Yeah. Oh, okay, so on exam 5, number 9 you said?
Yeah.
All right. So it says, know how to calculate the pH. So we're looking for pH of a solution. The pH of an acid. So this isn't really a problem, is it? It's like saying, okay, this is what will be the type of question on there. Should we make it a problem? What acid do you want to deal with? Should we deal with sulfuric acid? That's a strong acid. And how do we know it needs to be a strong acid? Because it says it neutralizes. If anything neutralizes, acid-base neutralizes, it's got to be a strong acid and a strong base. Okay? So we want to know the pH of, let's say, H2SO4. That's our question. Okay? And it says we know the volume of our acid. So let's just pick a volume. 250 milliliters of solution. Good enough? Pick whatever, right? And ladies and gents, on the test, you won't have to pick whatever. I'll give it to you, right? I'll tell you what it is. I'm just saying, if you want to study this stuff, I'm just telling you kind of what you need to know. And if you look at the worksheet problems that I gave you, this is how they are, right? And then it says you also know it neutralizes with a base. So a strong base, what's an example of a strong base? NaOH, anything OH, right? Okay. And you know the volume of that, with the volume of the base, so let's say we have 300 milliliters of this base, and we know the pH. What's the pH of a strong base? Close to what? 14. Should we just say 12 and a half? Okay. I don't know if this is true. I'm just plugging numbers, right? All right, so there's our problem. Does that make sense? And again, you won't have to make up your own problems unless you just want to try practicing some of these, right? But look at the worksheet if you want to follow something, okay? All right, so this is our unknown and this is our known. Let's start with what we know. We know everything about our base. Well, everything compared to our acid we do, right? So what can we find with our base information? Okay, so the number of OHs we have, it's a 1-to-1 ratio. Is that what you're saying? Okay, so it's a 1-to-1 ratio. But we don't know how many moles of this we have, right? We just have a volume. We don't have moles. Can we find moles? I don't know. What can we do with this? pH is 12.5. We can find the pOH, right? Why would we find the pOH? Because we're dealing with a base, right? A strong base. And maybe one of my students from my last class gave me this. Did you guys ever see this on some of the practice problems videos online? Okay. So, you want me to just write that up here? Might be useful. So the mole roadmap says moles of A going to grams of A, going to moles of B, grams of B. You follow? And it also goes to particles. We can stick that there. Particles of A, particles of B. And we said for substance A and substance B, right? We could also say for an acid, A is the acid and B is the base. Good? So from there, we can go to molarity. And so we know this is grams per mole, right? Or molar mass. And this is 6.022 times 10 to the 23. And this is just on your mole roadmap, right? And this is the mole-to-mole ratio on the balanced equation. And we're going to use volume. We're going to multiply volume, our moles divided by volume to get molarity, right? And if we're going the other way around, we multiply our molarity by volume to get the number of moles of our acid. You with me? So that's molarity of our acid. And then from there, we could, actually let's just change this to a arrow this way and an arrow this way. We can find our pH by using negative log of our H plus, right? And then if we have our pH, we can use 10 to the negative pH to find our molarity. You with me? There's one thing that's missing here, and that is if the ratio is not a 1-to-1, right? If it is a 1-to-1, then this is all you need. But if it's not, then you just convert it, right? You following me? And then from here, we can go to pOH using pH plus pOH equals 14. Then we could do the same thing with our base. Molarity of our base. And to find the pOH, it's negative log of our OH concentration, or 10 to the negative pOH to find our molarity of our base. And to find the pH, it's just pH plus pOH equals 14. And so this is kind of like a whole map to find everything we need. Think that would have helped earlier? Maybe? Sorry. Yeah. Anyway, would that help to have that on the reference sheet? Okay, no promises, but I'll see if I can get it there. I gotta condense this down, make it more readable, and then, yeah, we'll see if I can get it there, okay? So here we have our pH of a base. So we're right here. You with me? So we first need to find the pOH. And then, if we want to go this way, we can find the molarity of our base. Does that make sense? And then we multiply by the volume to find the moles of our base, and then use the mole-to-mole ratio from our balanced equation. Hold on a sec. Do we have a balanced equation in this problem? No, but it's a neutralization reaction. We're taking H2SO4 and we're neutralizing it with sodium hydroxide. So what do we get? This is an acid-base reaction. Double replacement. These guys are going to swap partners. We're going to get water and Na2SO4. Now, I may or may not give you that, but if I don't, could you find it? And then we got to balance it. So now that we use the mole-to-mole ratio, we have moles of A, but we need to find the pH, so we got to go clear to here. We're going to divide by the volume to get molarity, and then we're going to follow this arrow, negative log of a H plus concentration, but in this case, it's a 2-to-1 ratio, so we got to convert it 2-to-1. Does that make sense? Do you like that? Okay. I'm going to really try to put that on your reference sheet for you. It makes more sense after using it, and I don't know, I've never used that. I just kind of looked at it and says, okay, this is where I can go, but I'll start using that. That's probably easier, right? Okay. All right, should we work this problem? Okay, so I just mapped out a plan to get there. So I started here and ended here. So I have the pH of a base, so I need to find the pOH, right? And pOH is 14 minus the pH. So in this case, it's going to be 14 minus 12.5, which is 1.5. You with me? Okay, now I have that. I'm going to follow this path to find the concentration of my OH, or in this case, my base, because it is a 1-to-1 ratio. We good? So we go 10 to the negative 1.5 is going to give me my concentration of my NaOH. Are you with me? And so what's 10 to the negative 1.5? I can't do that in my head. So 0.0316. And you can write it as molarity or just moles per liter, right? And so from here, we have to deal with the volume. Good, we know the volume. So we have 0.0316 moles of NaOH per 1 liter of solution. You following? I use that, I don't use that again. I can use this, but not yet. What do I got to do with that 300 milliliters? Change it to liters. Anybody know what 300 milliliters is in liters? 0.3. And if you don't know, just convert it, right? So liters goes away. And now I have moles of NaOH, that now I'm here. And now I use my balanced equation to go from NaOH to H2SO4, which is a 2-to-1 ratio. You following? So we have 2 moles of NaOH on bottoms, so it cancels out, to 1 mole of H2SO4. Do you want to find an answer or keep going? Let's find an answer. But your choice, right? So 0.0316 multiply 0.3 divided by 2. Tell me what that is. .00474. Anybody else get that? We'll go with it. Okay, and that's going to be, what's my units? Moles of H2SO4, right? Okay. So now I'm here, and then I do something with my volume to get molarity. What do? Divide by my volume. So we use that one. Now we have volume here, but what do I got to do with that before I use it? Convert it to liters, because I have to have moles per liter. So 0.25 liters. Y'all with me, or am I going too quickly? Okay. And so that's my molarity of my acid. And now all I got to do is convert it to our concentration of hydrogen ions. Is this a 1-to-1 ratio? It's a 1-to-2 ratio, right? So for every 1 mole of H2SO4, we have 1 mole of H+. Y'all follow that? So that goes away. And we find an answer here, and this is my H+ concentration, moles per liter. So what's 0.00474 divided by 0.25? Uh-oh. Yes, that's supposed to be a 2. So 0.00475 divided by 0.25 multiply 2, and we get 0.37. Okay. 0.38 molarity of H+. So once I have this, I just do negative log of that, right, to get my pH. And that gives me something. Okay. 0.42. Is that what we're getting? Okay. So my acid is very acidic, right? Okay. Did that help or no?
Just takes forever.
Yeah. So if you have a map, it might make it a little simpler, right? And then just do one step at a time until you get there, some of you. Some of you like to just blast it out in one problem. Your call. We good? Anything else? Okay, let's go home. Just kidding. I'm just teasing, guys. Yeah.
Can we quickly go over like setting up the equation if we're not given it, what information we're given to set up an equation like we did?
Okay, yeah. So if it said, so I'll do a different one here. So if it said we have HCl neutralizes with NaOH, for example. Well, if these neutralize, what does it mean to neutralize? Here's the pH scale. What's neutral? What is that? Water. So when it neutralizes, we're making it into water that's not acid or a base. So we got HCl, that's this one, plus NaOH, that's that one. And then remember acid-base reactions from last unit? The two cations swap partners. So sodium comes over here with chlorine, and sodium is Na plus, chlorine is Cl minus. Do you understand this? Cross charges, and it's just going to be NaCl. And then the hydrogen comes over with the OH and makes what? Water. Do you get that? So that's kind of what I did up here. The H goes with the OH and makes water. The Na goes with the SO4 and makes sodium sulfate. But we still had to know the charges, cross the charges, just like we did Unit 2, right? Did that help? And then, of course, we got to balance it. In this case, this one's already balanced. Other questions?
Are we just doing like chapter 5 or can we go over
You can do whatever you want, yep. Yeah, some questions are better than none questions, so. You have a question on the final exam?
Yeah, I was looking at number 20.
Number 20.
I mean, I kind of have it, but it's just about the
What is the mass number of an atom that has 12 electrons, 12 protons, and 14 neutrons? So what is the mass number? Do you guys remember?
number of protons.
Protons plus neutrons. Because remember, the mass of a proton is 1. The mass of a neutron is 1. The mass of an electron is 0, relatively speaking, right? So the mass number is protons plus neutrons because they both have a mass of 1. So in this one, we say we have 12 protons and 14 neutrons. That means our mass number is 12 plus 14, which is 26.
And that's the number in the upper left corner.
That's right. So in this here we have, so this is our base, our generic symbol for an isotope, where this is our mass number, the top number. And what's the Z? That's our atomic number.
That's the protons, right?
Yeah, the number of protons in an atom, or just the number of the element on the periodic table. Good? And then, of course, the X is just the element symbol.
The element 12.
So,
Magnesium.
yeah, it has 12 protons, so yeah, it's magnesium, so it's going to be Mg26. There you go. Make sense? And if it has, how many electrons does it have? 12 electrons, so what's the charge of this isotope? Has 12 protons, 12 neutrons, they cancel out, right? So it is neutral.
Has 14 neutrons, or is it the protons and electrons?
On 20?
Yeah.
Yeah, there's 14 neutrons, 12 electrons, and 12 protons. Make sense?
Yeah.
Is that going to be useful for nuclear chemistry as well? Yeah. Yep. What else?
31 on the final secondary.
Okay.
About,
31 on the final exam study guide.
yeah.
So it says a compound contains an unknown ion X and has a formula of S3. The X ion contains 10 electrons. What is X? Well, if it's an ion, what does that mean? It lost or gained electrons. After it lost or gained electrons, it now has 10 electrons. You with me? All right. So what did it do? Did it lose or did it gain electrons? X is the cation. What do cations do? To become a cation, an atom has to, yeah, it is positive. So does it lose or gain electrons? Loses because electrons are negative, right? Loses negatives becomes positive. You with me? Okay, so let's think about this. Do we know the charge of X? No, because it's not on the periodic table. Can we figure out the charge of X? Yeah. Do we know the charge of sulfur? What is it? 2 minus. And how many are there? 3. That's a total charge of -6. And all ionic compounds are neutral. So the cation sign has to be +6 total. There's a total of 2. 6 divided by 2 is 3 plus. All right. So the X3 plus ion has 10 electrons. How many did it have before it became an ion? Cations lose electrons. How many did it lose? 3, right? Because it's 3 plus. How many did it have before it lost 3? It has 10 after it lost 3.
13.
So it has 13 before it lost 3. Huh. And before it lost 3, it was neutral. It has 13 electrons, so how many protons does it have? 13. You get that? And what element has 13 protons? Aluminum.
So aluminum 3 plus.
Well, it's just asking for what is X, so it's just aluminum. But yeah, this ion is aluminum 3 plus. We good? Yeah, you'll have to be able to do that. On the final. If you guys just rock the exam 5 and you're good with your grade, it looks like you don't have to take the final. But if you want to just take the final because you just want to up your grade even higher, do it. Right? Anything else? Are we good with half-life problems? Should we do some of those? Yeah, let's do a few examples. I'm gonna look up your worksheet that I gave you, so I don't have to. Is that okay? All right, let's do a few examples of half-life problems, and this is from last time. If anybody wasn't here. Well, none of you is here. Sorry. My bad. Okay, it says, what is the half-life? So, did anybody not watch this video? Okay, I would still watch it. Because, I mean, ladies and gents, if you, I can reteach you this if you want. But then we don't have time to review so please watch that. Okay? It's the last video on that list that I gave you. So half-life, you guys know what half-life is? It's the time it takes for half of a radioisotope or a unstable isotope to decay. Okay? And why do we even deal with this? What is this? This is a probability. It's just like flipping a coin. Half the time it's going to be heads, half the time it's going to be tails. Is that 100% true? No. And it's the same way with this. It's not 100%. It's a prediction. Okay? So we want to know what the half-life is of a substance if we have 100 grams to begin with, and then it decays until we have 12.5 grams of this substance. And the time it takes to do this, the total time, is 21.6 seconds. All right, so maybe I ought to start with a simpler one first. Because since I'll just go with it, since we already have it set up. So at time 0, how much of this sample do I have? 100 grams. Y'all with me? We start with 100 grams and end with 12.5 grams. So when we start that stopwatch, that's why I just say time 0. 1 half-life later, how much do we have? 50. 1 half-life is the time it takes for half of the sample to decay. So half of 100 is 50, so we just divide it by 2. You following? Well, we're not there yet, so we keep going. After 2 half-lives, how much will we have? Half of our new amount, which is 50, so which is 25. Good? We're still not there, so we keep going. After 3 half-lives, we have 12.5. We're done. So 3 half-lives goes by, and that's 21.6 seconds. What's 1 half-life? 21.6 divided by 3 half-lives later, right? 7.2 seconds that's our half-life. Do you get that? Someone's dying. Sorry. Okay. Any questions on that? Yeah, Sandy.
How did you get the time in half-life? I just got lost with how you got the 7 point.
Okay. Yeah, so we take the total time it says is 21.6 seconds, right? So that's from the time it takes where we start to where we end. This is 21.6 seconds. And we cut it in half 3 times. So that's 3 half-lives. We want to know what the time is for 1 half-life. So we take 21.6 and we divide it by 3. And that gives us 7.2 seconds. Make sense?
Yeah.
Thanks for asking. We good? Should we do another sample? Yeah, we could. Let's see, half-life. Let's say that we do have the half-life this time of 0.025 seconds. And we want to know how much time passes if we start from 560 gram sample and we decay to 1/4 of its original mass. What's 1/4 of 560? Anybody? Somebody? One buddy? I have a calculator right there. I would use a calculator on the test for sure every time.
But it's fun to try.
It is. 140
140.
grams. All right. Are we going to set it up the same way, guys? What do I have in my original sample at time 0? Can you take 560, right? And we're going to do what until we get to 140? Cut it in half, right? So 560 divided by 2 is? 280 divided by 2 is 140, right? Okay, so 2 half-lives. 2 of those guys, right? So what's our total time? 0.025 multiplied by 2. And that's going to give us a total time of 0.05 seconds. Good? So that's 2 examples that are 2 different things that I could be asking for. Let's do another one. So let's say we have half-life of our sample is 12.4 hours. We want to know how much of an 848 gram sample we have after a total time of 62 hours. So I can start it the same way. At time 0, how much do I have? 848 grams. We don't know how much we have at the end. We got to figure that out. Can we figure out how many half-lives we have? Yeah, total time of 62 hours divided by each half-life is 12.4 hours. And what is that? 5? Or no? 5? So we're going to go 1, 2, 3, 4, 5. We're going to cut this in half 5 different times. 848 divided by 2 is 424. Divided by 2 again is 212. Divided by 2 again is 106. Divided by 2 again is 53. Divided by 2 again is 26.5. You following? And ladies and gents, I just didn't use my calculator. Use your calculator on the test. Don't mess up on a stupid thing like that, right? You just divide it by 2 until you get there. Did I do it right? Okay. What if I was looking for this guy? Can I do that? What if I said, how much do I have left? If I end with 26.5 grams, and it takes this much time and each half-life is 12.4, what do I do? I know what the answer is, obviously, but I start with my end, because that's what I know. I start with 26.5. That's my last half-life, and I'm not sure what that is. I'm not sure how many. Can I figure that out? It's right here, right? 62 divided 12.5, that's 5 half-lives. After 5 half-lives, I have 26.5. 3, 2, 1, and we do what? Multiply 2 each time until we get 848. You follow? Those are the different questions that I could ask you. Do you see how it's the same process every time? You're just looking for something else? Okay, I'm not saying it's easy, guys. I'm saying those are the different things that I could ask you. Anything else?
We have more stuff from the final review.
Yeah. If no one else has any questions, go for it.
I just wanna go over free energy, entropy, and
Oh, we can't do that one. No, which one is it?
51.
I'm just teasing. 51 on the final exam study guide. Know how to determine the free energy, delta G. Know how to determine the enthalpy, delta H. Know how to determine the entropy, delta S. Know how to determine if they are positive or negative. And you're given a balanced equation and this formula. Okay, so let's see. Let's say we have H2 plus O2 gives us H2O, for example. Let's make sure we have it balanced. There we go. So let's start with the easiest thing that we know. And maybe it says plus 62 kilojoules. I'm not sure if that's true, but let's just say that, okay? What does this tell us, guys? That it's exothermic or endothermic? Exo, we're releasing the heat, right? So is that a positive delta H or a negative delta H? If it's exiting, we're losing it. Losing it means it's negative delta H, right? So that's negative. What about, so if we can figure out what this is, we can figure out what that is, right? What's delta S? What is that? Entropy? What does that mean? Measure of disorder. So let's see. If it goes from here to here, is that going toward more order or more disorder? More order. We're going down to smaller things, right? We have 3 things going down to 2 things. We're getting less chaotic, right? More order. So what is more disorder called? Positive or negative entropy? Positive, because it's a measure of disorder. So that means a measure of order is negative, right? And if they're the same, then we can figure out this. Now, if they're the same, I don't know if I'll ever give you this on the test, because that's the hard case. And that's the case where you need to know a little bit more, right? But let's just try to think about this for a minute. If this is a negative number, and we subtract, and this is measured in Kelvin, right? And this is a negative number. We subtract a negative number. It all depends on how big that temperature is, right? Because negative minus a negative is negative and a positive, right? So it depends on which number is bigger. It's going to be positive or negative, right? But ladies and gents, don't worry about that. Because then you have to know, well, what is this? What temperature does this happen? Do you guys know that? Yeah, and I don't expect you to know that. So I kind of gave you a hard one. Let's do an easier one. If delta H is positive and delta S is negative, if they're opposites, what is delta G? Well, we have this equation to guide our thinking. Delta G is equal to delta H minus, T delta S, right? We have a positive number. Let's change this color so we can see a positive minus a negative. What's minus a negative turn into? Positive. That means delta G is positive. What if delta H is negative and delta S is positive? Delta H is negative minus a positive is more negative. You follow? But do you see a pattern here? If these are opposites, then delta G follows the delta H. And what's delta G stand for? That's the free energy, right? Gibbs free energy. Well, what is that? Spontaneity, right? If it's spontaneous or not. Do we know if this is spontaneous? Do you guys know that? So there's a lot of unknowns that way. So, but if it's like this, I mean, guys, if I gave you this, whoops. Can you tell me if that's spontaneous or not? Probably not, right? So spontaneous, if it's spontaneous, then it's negative delta G, right? And if it's non-spontaneous, it's positive delta G. But we don't know that just by looking at this. Therefore, I'm not going to ask you that. All right? But if I told you what this is, I bet you could. This is propane. What happens if we propane and oxygen? If we give it a little spark to get it started, do we have to keep giving it energy? So this is spontaneous, which is a negative delta G, right? But I wouldn't stress too hard about that. If you can, do you understand using this formula? Yes or no? Okay, no, not quite. No, watch. I'm going to show you another way. So we have delta G equals delta H minus T delta S. Okay, so if I know my delta H and my delta S is positive and negative, let's put a number in there. Positive 1 and negative 1. And let's say my temperature is 1. Why do I pick 1? Because they're easy, right? And let's see what happens. 1 minus a negative 1 times a 1 is a negative 1. What's 1 minus a negative 1? Type that in your calculator and it gives you 2. Oh, it's positive. You with me? You can just plug any number you want. I like to pick 1s because they're easy. And so if delta H is negative 1 and delta S is positive 1, then we got negative 1 minus a positive 1. What's negative 1 minus 1? Minus 2. Oh, so that's a negative. Good? Did that help? I call that the unit test because you're starting with 1. What?
What does the H stand for?
Enthalpy.
Entropy.
Enthalpy. Entropy is S.
And that's, what, it's endo or exothermic?
Enthalpy is endo and exo, yep. Where the heat is going. Endo if it's coming in, exo if it's leaving the system. And I don't know if this will help. This is energy. And if it does this, we start here and we end here. What are we doing with the heat? We're getting more. We're gaining it, right? So this is endothermic. And this is our activation energy. And this right here is my delta G. My change in anything, change in something, is equal to final minus initial. My final energy is big number, minus my initial energy is small number. That's a positive delta G. I have to keep giving it energy the whole time. So that's non-spontaneous. Good? Am I going too much? And then if we have something like this, my delta G here, my final is a lower number minus a bigger number, 1 minus 5. Just pick numbers in my head, right? Final minus initial, that's a negative. So this is a negative delta G. And I give it a spark, and then it goes the rest of the way by itself. Spontaneous. This is also exothermic. Why? Because we end with less energy than what we started with. We're losing energy. It's exiting the system. Good? What else?
I got one more.
Uh-huh.
We'll just review the intermolecular forces, number 59.
Okay. Know the types of intermolecular forces and determine which is predominant. So that's basically what we deal with anyway, right? So we have different types of intermolecular forces, IMFs, right? So we have ion-ion. What kind of compounds are ion-ion intermolecular forces? Ionic compounds. So this is between ionic compounds. And do you guys remember what intermolecular force is? Here we go. If we have a water molecule, remember this is partial negative, partial positive, then we're also always going to have another water molecule, partial negative, partial positive. These guys attract a little bit, yeah? This attraction between molecules, not inside molecules, but between molecules, this is the intermolecular force. It's not a bond, it's just an attraction, attractive force between molecules. So the attractive force between ionic compounds is called ion-ion. So if we have an ionic compound, we know the dominant intermolecular force is ion-ion. Good? If we have another one is hydrogen bonding. And hydrogen bonding are for polar covalent bonds. But specifically, when hydrogen is directly bonded to, do you remember? Nitrogen, oxygen, and fluorine. Only those. Why those three? Because they're the most electronegative. Good? So if we have a polar molecule, do you remember how to tell if it's polar? Okay.
Look at your,
Molecular geometry. And see if you can do the line test. But if it has lone pairs, then it's polar, right? Around the central atom. Okay. And then we got dipole-dipole. Is also for polar covalent. And we're talking about the rest of them. Anything that's not hydrogen bonding. Good? And the weakest is London dispersion, which is for nonpolar covalent. And so the strength increases this way. Strength. If I can spell right, goodness gracious. And if it's stronger, if the traction is stronger, it's going to be harder to break that attraction, right? So that means the melting point and boiling point increases as the strength increases. What if they have the same intermolecular force? Now which one has a greater melting point? The bigger one, or the more massive, the higher molar mass? Good? Okay, I need to take a quick break. Look over that review, that study guide. Come up with more questions. Anything else?
I have a question about grading. So we need to do the final practice exam regardless of if we take the test, right?
No. The final practice exam does not go on your grade. Period. Sorry, I should have mentioned that in my last class. Yeah, it doesn't go on your grade. So if you decide not to take the final, it's not going to affect you. But if you're going to take the final, I would do it. Okay? Anything else?
Is that all my questions?
Since Andrew doesn't have any more questions, we're all done. Thank you, Andrew. So go through. Are these useful? Is it hard to follow?
I like it.
Okay. I know some of them you might have to, what is that even saying? What kind of problem is that? But Look at the, if you revisit the worksheets that I gave you, they're similar to the ones on the worksheet. Okay? Well, if you have more questions, you can stay. If you don't, I don't want to hold you here longer than you want to be here. So, doesn't make me feel bad, because if everybody's gone, I gotta go. I'm not saying get out of here either. Okay, thank you. Study, study, study. Let's rock this exam, and maybe we don't have to take the final.
I have to take that final.
Okay.
I have two questions. I forgot about exam 5. How do I take that one? Do I schedule that at testing center?
Exam 5 is here in class. Oh, did you want to? It's next Thursday, or this Thursday.
Oh, it's this Thursday. I thought I missed it because it has the date of December 2nd. I was like, oh, I guess I missed that over the weekend. So this Thursday is in-person exam?
Yes.
Okay,
You gonna be able to make it?
okay. Yeah, no, I'm here Thursday.
Okay.
And then the final will also be in class.
In class, or if you want to take it in the testing center, you can up until the 12th. So if you need extra time,
Oh.
but if you don't take it in class on Tuesday,
Mhm.
then you have to take it at the testing
You
center.
have to, oh, okay.
So
Okay.
your choice, and you don't have to let me know. Just if you're not here, I'm not gonna wait for you if everybody else is done.
Okay, thank you.
Good?
Mhm.